This is problem number 7 from Mathematics Paper 1, Time Zone 1, from May of 2015. Now, I think I gave you this question as one of the ones that I wanted you to do, but I figured it might be helpful to perhaps go over it with me talking on top of it. Maybe that makes it worse, having my voice on top of it. I don't really know. But here we are. So let's start going through it. This tells us that we have a shaded region, R, right here, and we're given some boundaries of that shaded region, specifically that it starts when x is equal to 3 pi over 2. It ends at this value b, where b is greater than 3 pi over 2. And the x-axis forms the bottom of that region. And we're told that that area, the value of that area is 1 minus the square root of 3 over 2, and we're asked to find the value of b. So the first thing to jump out at you is the fact that you are being asked to find the area of a region tells you that you're probably looking at an integral, specifically an integral of our function, which is cosine of x dx. And let's look at the limits of integration. We know that the bottom limit is going to be at 3 pi over 2. So we're going to put 3 pi over 2 as our lower limit. And we know we're integrating up to this value b, which is what we are being asked to find. So we don't know what b is, but we can actually evaluate this integral with b as the upper limit and then set that equal to what we know the area to be, and that is this 1 minus square root of 3 over 2. So this is where we first start by thinking about antiderivatives. If f of x is cosine of x, then we know our antiderivative f of x is going to be sine of x. And so to evaluate this integral, we're going to evaluate our antiderivative at b and subtract the antiderivative evaluated at 3 pi over 2. So that is going to be sine of b, that's at the upper limit, minus sine of 3 pi over 2. And so this just simplifies. Sine of b stays as sine of b, but we can evaluate sine of 3 pi over 2 and get that that's negative 1. And so this expression just simplifies to be that sine of b plus 1 is what that area equals. Now let's set that sine of b plus 1 equal to what we see is the area, specifically 1 minus square root of 3 over 2. And that is, one more time, what we identified up here is the area of that region. So looking at this, we can see then that the 1's subtract out, and we're left with sine of b is equal to negative square root of 3 over 2. And there is the unit circle question. Again, this is something, it doesn't go away, folks. We know that b is between 3 pi over 2 and 2 pi. Thinking about our quadrants then, that means that we are somewhere in quadrant 4 right here, and we need to decide where sine of b is equal to negative square root of 3 over 2. And so we can think about where that is. We can play around with that a little bit and get that the value where that has to happen is going to be somewhere around here. Okay, we're not quite to the pi over 4, we're not quite to the pi over 6, so it has to be this one, which tells us that b has to be 5 pi over 3. And there is our final answer for the question.